Hi there. Today we're going to be doing the types of compounds lab. So in our introduction, it says we already learned that compounds are made of different elements held together with chemical bonds. We also know that different elements have different properties. But what happens to those properties when these elements form compounds? This lab helps us to better understand molecular structure, which has us look at how the attractions between atoms and particles affect bulk properties. So how do the attractions between particles affect bulk properties? And to better answer the essential question, how is the stuff of the universe held together? So in part one for our method, we are going to explore properties of a selection of different compounds. And we're going to see how they behave. We're going to then use those properties combined with our knowledge about types of elements to separate them into different categories. So there are two main categories, ionic and covalent. So there are a couple of questions that I want you to answer. If ionic compounds contain metals, will they conduct electricity? So use your knowledge of metals to decide whether you think they'll conduct electricity, yes or no. 2, if covalent compounds contain only nonmetals, so knowing what you know about nonmetals, will they have a high or a low melting point? And then number 3, which compounds do you think will dissolve in water? Ionic, covalent, or both? So the different compounds that we're going to test in lab today are calcium chloride, urea, sodium bicarbonate, potassium iodide, sucrose in the form of sugar cubes, and naphthalene in the form of crushed up mothballs. For each of our compounds, we're going to test a selection of different things. So we are going to make notes on the appearance. So we're going to take a look at how they appear. We're going to test whether they dissolve in water, so their solubility. So we're going to add some water, see if they dissolve. We're going to test their conductivity, so whether or not they conduct electricity. We're going to test both in solution, if it dissolves, and as a solid. So we're going to test conductivity twice. And then we're going to look at the melting point. So we're going to see if it requires a high temperature or a low temperature to be able to melt. Okay, so we're going to go down our list. And let's start with our calcium chloride. I'm going to move everything else off to the side. I'm going to go ahead and turn my hot plate on just so that it's ready to go. Okay, so we're starting with calcium chloride. And I'm going to take some of this and I'm going to pour it out into a little aluminum weigh dish here so that we can, even though we're not massing it today, it still makes it easy for us to be able to see. So I'm going to tip that. The lighting is not the best. I'm going to drop in a still picture of this so that you can pause the video if you want to be able to make notes on what it looks like. Okay, after we test appearance, we are going to test solubility. So I'm going to take a small test tube and a scoopula, and I'm going to scoop some of my solid, so just a small amount, just the end of my scoopula, into my test tube. So there's a little bit down there at the bottom. And then I have my distilled water bottle, so I'm going to add some distilled water to it, just a squeeze. And then I'm going to use my stir rod to give that a stir. You can already see it starting to dissolve a little bit. And it is definitely dissolving. So there is no solid left at the bottom. So for solubility, I'm going to say yes, it is most definitely soluble in water. Okay, I'm going to set my test tube off to the side, give my stir rod a rinse. Okay, for conductivity, I'm going to test it two ways. So I'm going to test conductivity as a solid, and then I'm going to test conductivity in solution. So my conductivity probe is turned on. The way this works is if it conducts electricity, it lights up. If it doesn't conduct electricity, it doesn't light up. So I'm going to be careful when I test the solid to not touch it to the metal, because we know, uh-oh, this one I think might have a dead battery. Oh, no, it's good. There it goes. I just wasn't doing it quite right. Okay, so I'm going to be careful not to touch the aluminum dish, because that is for sure going to light up. I'm going to make sure that it's just in the solid. And if you look at the lights, they are not lighting up. So this is not conductive as a solid. So we will say no. Oh, that's lovely, the bell. Okay. For my solution, I can't fit my probe into my test tube, so I am going to go ahead and pour my solution into a different weigh boat. So I kind of end up with a puddle on the end. And then I'm going to go ahead and test my solution. And maybe you can see it, but the red light definitely, there you go. Yep. The red light lights up, therefore it is conductive in solution. So no for a solid, yes for solution. Okay. Our last test is I'm going to go ahead and set that off to the side. Our last test is to test melting point. So we're not looking for a specific number here. We're just looking for general high or low. So with our hot plate that we have, if it melts, it's low. If it doesn't melt, it's high, because our hot plate doesn't get hot enough for it to reach what is considered high temperatures for melting points. So I'm going to take my aluminum weigh dish and I'm going to put it on my hot plate, and I'm going to take some close-ups so that we can see what it does while it maybe melts. You might be able to hear it sizzling a little bit. It's doing some little popping stuff. It is not melting though. And it definitely smells like something's burning. Okay, so it's been about a minute that it's been on the hot plate, and it hasn't done anything except honestly smell like it's burning. So I'm gonna go ahead and take it off the hot plate, and we're gonna say that calcium chloride has a high melting point, because it's not melting. It's not doing anything. There we go. Okay, on to our next sample. So we are done with the calcium chloride. Moving on, the next one that we are going to do is the urea. So that's the next one on our list. So here's my bottle of urea. I'm going to do the same thing. I'm going to put some in a weigh boat, an aluminum weigh dish, so that you can take a look at it. Set that off to the side, and I'll hold this up so you can take a look at it. And then I'm going to take a picture so that you can see a nice still close-up of what this looks like. Okay, after appearance, we are going to look at solubility. So I'm going to get a clean test tube, and I'm going to get some of my urea and put it into the bottom of the test tube. Add some distilled water. give it a stir. So it's dissolving, maybe not quite as quickly as the calcium chloride did, but it is dissolving, so we are going to say that it's soluble. There's the last little bit in the bottom. So urea is soluble, so you can look at it. It's all dissolved into the solution. There's no solid left. Okay, I'm gonna set that off to the side. Give my stir rod a rinse. Okay, testing conductivity. So we are going to test the solid first. Again, same with the calcium chloride. I'm going to be careful not to touch the aluminum dish, just so that I'm getting just the sample. And I don't see any lights light up. Okay, so not conductive as a solid. I'm going to take my solution that was in my test tube and put it in a clean weigh boat or aluminum dish so that we can see if this one conducts. There is a very, very faint light. You may not, yeah, you might be able to see it just a little bit. Very, very faint light on that one. So we can say that it's kind of conductive in solution. It's not very conductive though, not nearly the same conductivity as the calcium chloride. Okay, and then the last one is to look at melting point. So we're gonna do the same thing. I'm gonna take my weigh boat or my aluminum dish of urea and I'm gonna pop it on my hot plate. A little hot. That melted very quickly, so it definitely has a low melting point because that for sure melted and it melted very quickly. Probably don't need my hot plate quite that hot. Okay, so that was urea. We had its appearance. It's soluble in water. It's not conductive as a solid. It's barely conductive as a solution, and it has a low melting point. Okay, next one is our sucrose. So again, my sucrose is in the form of a sugar cube. Just for consistency, I'll put that in my weigh dish, my aluminum dish. So there you go, there's my sucrose. And just to make this a little bit easier, I'm going to go ahead and crush it up a little bit. Because I really don't need to test all of this, I just need some of it. Okay, so crush some of that up. Made a little bit of a mess. Okay. So my sucrose, let's test its solubility. So clean test tube. This one, just based on your experience with sugar, you probably already know the answer to. So put some in my test tube, add some water, give it a stir. And it's definitely soluble. It all dissolved in water. Okay, so my sucrose is soluble. Okay, let's test some conductivity. So conductivity as a solid is a definite no. There's no light coming on when we put it in the solid. So let's test it as a solution. So there it is. And I don't see any light with that one. So we're going to say that sucrose is not conductive as a solid or in solution. So I see no light when I put it in. Okay, and then the last piece is for the melting point. And before I do this one, I'm going to go get tongs to be able to grab this off. Okay, and we're back. So I'm going to put my whey boat on my hot plate. And this one definitely melts. So it has a low melting point. This one actually doesn't smell bad. It smells kind of like marshmallows. Okay, so sucrose, we have the appearance. It was soluble in water, not conductive in solid, not conductive in solution, and has a low melting point. Up next is sodium bicarbonate. So this guy. So here's what we got. That's our sodium bicarbonate. I'll take a picture for you. Okay, so that's appearance. Next up is solubility. So clean test tube. Grab a little bit of the sodium bicarb. Add some water. And that one, I don't even think I need my stir rod. I'll stir it anyway, just to be consistent, but it pretty much immediately dissolves. So sodium bicarbonate, definitely soluble. Okay, conductivity. So we'll test it as a solid. Nope, no light, not conductive. And then we'll test it in solution. Definitely conductive. You can probably see it light up here. Let me see if I can hold it this way. Yep, there's the light. So definitely conductive. Okay, so sodium bicarb is not conductive as a solid. It is conductive in solution. Okay, and finally, melting point. So pop that on my hot plate. Well, it's been about a minute and it's not doing anything. So it is not likely to melt. So we are going to say that sodium bicarbonate has a high melting point because it is definitely not melted. Okay, 2 more to go. Potassium iodide is our next one. So that's this guy. Give it a shake because it's a little solid on the inside. Okay, pour some into my weigh boat. There you go. And just like all the other ones, I'll add the picture. Okay, so solubility first. Clean test tube. Take a small amount, pop it in the bottom. Add some water. Oh, that one I definitely don't even need to stir. But just for consistency, and because our procedure technically tells us to, give it a stir. It is definitely soluble. There is nothing left. So potassium iodide is for sure soluble in water. Okay, conductivity. Not conductive as a solid. Okay, and then we're going to test our solution. There it is. Definitely conductive in solution. So not conductive as a solid, yes, conductive in solution. Okay, and then we're going to do melting point. So I'm going to use the last little bit that's in my weigh boat, pop it on my hot plate. Okay, so that's about a minute. It didn't do anything. So it has a high melting point because it did not melt at all. Okay, last one is naphthalene. So naphthalene is also known as mothballs. So you can actually buy it in the store, and some people like the smell of it. A lot of people don't. So it is a unique smell. And it is a unique experience that you are missing out on since I can't send smell through video, but it smells. I don't think it smells good. But here's my naphthalene. So it is actually crushed up mothballs that I'm pretty sure I bought from Walmart or Target or someplace. Hence why it's stored in just a Tupperware container. But I'm going to take some of this and add it to my weigh boat, and then put the lid back on because, like I said, it stinks. Okay, so here we are. I don't know if you can really see, it's kind of sparkly. Let's see if I can get it in a picture. Okay, first up, solubility. Test tube. small amount. Add some water. Okay, this one's a little bit different. So if you notice, it like actually floats on the top. So I'm gonna give it a stir, but it does not look like it's dissolving. Actually, kind of looks like a snow globe. Nope. So I'll just sink into the bottom. I don't think any of it has dissolved. Okay, not soluble in water. Not soluble in water. Okay, let's look at conductivity. So testing it as a solid. Not conductive, no light. Okay, so not conductive as a solid. Let's check it as a solution. And actually this one's weird because there isn't really a solution because it didn't dissolve. So actually we don't need to test it in solution because the solution doesn't exist. In order for a solution to be a solution, the thing had to have dissolved in it. So it's not there. It's just the solid floating in water. So it's not going to conduct because we already know that the solid doesn't conduct. So we can skip that one. We can put an X in it because we can't test the solution if we don't have a solution. Okay, last one, melting point. So that one melted almost instantaneously. So that is definitely a low melting point. So let's go back. Oh man, it smells so bad. Oh God, that's bad. Oh, the joys of chemistry. Okay, so let's go back through. You have your appearances for all of the different solids. Solubility, everything was soluble in water except for the naphthalene. Nothing conducted as a solid. In solution, calcium chloride did, urea kind of did, sucrose did not, sodium bicarb did, potassium iodide did, and naphthalene did not because we couldn't test it as a solution. For melting points, calcium chloride is high, urea was low, sucrose was low, sodium bicarb was high, potassium iodide was high, and naphthalene was low. So the next thing you're going to do is you're going to start to find some patterns in these properties. So you'll probably see that they, for the most part, divide themselves into two categories. There might be a few that are a little bit odd here or there. And so you're going to look at the differences between ionic and covalent. So to help you along the way with this, besides properties, you can also identify ionic and covalent by the types of elements. So covalent compounds are going to have only nonmetal elements. So carbon, nitrogen, oxygen, sulfur, hydrogen, all of those sorts of elements. No metals. Ionic compounds are going to have metals and nonmetals. So you're going to have things from both sides of the periodic table. So you can use those coupled with your properties to kind of categorize between whether something is ionic or covalent. And so from there, you should be able to answer the rest of your questions for your lab conclusions and results. And there you have it. That's our exploration of the different types of compounds and their properties.